All right. So let's jump into starting with big O and runtime analysis, and then we can sort of tie that into sorting, and then we can talk at a high level about how sorting happens in JavaScript, which is pretty easy. I'm gonna stop sharing so I can share my whole screen, because right now I'm just sharing this agenda. So let's do that. Cool. So I'm gonna go into just a very basic environment. I'm gonna mute your background noise, Olga, if that's okay, just because there's a couple people talking in the background, but feel free to unmute at any time. Thanks. All right. So with that, let's open our sorting space. Don't worry about it. So what I've done is I've just gone through and set up a node project. This isn't React or any front end or back end stuff. It's literally just a node project with package.json. And we've installed a couple of dependencies here so we can run TypeScript, but you don't even have to do that. We could do this all in JavaScript if you want to follow along. And so I just have my main.ts and I can run this pretty easily. If I do npm start is the script that I made. And so this is used as a package called tsx, which compiles and runs this TypeScript file. I was trying to get Nodemon to work, and for some reason it was not having it today. So we're just using tsx instead, which runs it individually. All right. So let's say I have a random array here, names. And I have my name, I have Anton, I have Olga, I have, trying to remember offhand who else is in here. I have, oh, there's a bunch of people now. Do one more just off the top of my head. I know there's other people in here. All right, so I have this list. I want to sort it. Maybe I get this data from an API somewhere and I need to display it in a list on my page. And so I need to sort it. And I said we're going to do big O first, but actually we're going to go the other way. We're just going to talk about sorting first, since I have it up here anyway. So if I want to sort an array in JavaScript, which you guys will do today, or this week rather for your assignments, all we have to do is take the array and call .sort on it, which is a function of an array that takes this and sorts it in place. If you hover over, it says this sorts in place. What does in place mean? In place means it uses the same array. It's just going to swap the order of things, and I can just call my variable and use it somewhere, and it will be sorted. If it's not sorted in place, that would imply that it's creating a new array that is sorted, and then I would have to assign that to a variable, new names. And then this original variable, this array would still be unsorted because it created a new one. So just be cognizant. We do sort in place in JavaScript. So I can get a reference to it. New names and names in this case are the exact same array. This is going to be sorted, and then this is going to give me another reference to that same array. So I can console.log my names here, and we'll knock this out. And then again, if I npm start, we'll see that it's sorted, and we have Anton, Brandon, Eli, Nihal, and Olga. Cool. So that's sorted. One thing to note is by default, it's going to sort according to natural ordering of whatever's in your array. So if we have an array of strings and I try and compare strings, it's going to compare them lexicographically. So it's going to start by anything that has a letter that comes before another word that will come first. And then also we prefer things that are shorter than things that are longer. If I put Elijah in here, it has the same prefix as Eli. And you'll note that Eli comes first. So this is how strings are compared. This is going to be the same in basically every single language. And numbers work the same way. If I sort an array of numbers, then it's going to put 1, 2, 3, 4. instead of the other way around. But we don't always want to do that. Sometimes we want to sort things differently. Maybe I want to sort this in descending order instead of ascending order. Well, the way I can do that is by providing a custom comparison function. So if we hover over this signature, you'll see that this is a function of an array type dot sort, and then the argument it takes is an optional argument, which is either this function with this sort of gross looking signature right here, or we don't have to pass it at all, which is what we're doing right now. We don't pass it, and therefore it's undefined. It can be either one. If it's undefined, it's just going to use the default comparison function for whatever you're comparing. And then it's going to give us back our new string array, which is in place. So I could very easily swap the order here by giving it a different comparison function. We're going to give it a reference to a function. And what this comparison function is it's taking two arbitrary elements, and you have to return a value, a number that tells the function which one should come first. So if I have two arbitrary elements, I'm going to call this A and B, and these are strings. I don't have to put a type on here. It's going to like naturally just assume that it's a string since we're using TypeScript and this is an array of all strings. But if I were to like put a number in here, now these can be either a string or a number, which doesn't make a whole lot of sense. So we have two arbitrary strings, and we need to figure out, does A come first or does B come first in the ordering that we want? And if A comes first, then we're going to return a negative number. Doesn't matter what negative number, it just has to be negative. And if they are equal, then we're going to return 0. And if B comes first, then we're going to return a positive number. And the logic under the hood of this sort function, which is not in here because this is going just into the type declaration for this function, not the actual implementation. Under the hood, it's going to use this comparison function, and it's going to compare a bunch of strings against each other. Not every single string against every single string, but some ordering that allows it to move things around appropriately. And it's going to call this function for any two things it's comparing at one time. And depending on which one comes first, it might swap them around and move on to a different pair of strings. We don't have any idea how that works yet. We'll talk about that in a second. But all we have to do here is we just have to return our negative number, our 0, or our positive number. And in any language you're working in, there's going to be some really helpful methods for comparing types, or you can do other kinds of things. But in JavaScript, we can compare strings by taking a string and calling the locale compare function, which you'll notice returns a number, and it just compares these two strings in the current locale. So I don't know exactly what this means, but depending on where you are, maybe it converts the string, like the characters into valid characters and then compares it from there. I don't have any idea what the implementation here is, but in our case, it's not going to do anything. It's just going to compare the two strings. And I happen to know that this comparison is going to do this -1, 0, and 1 return value. So if the caller here is supposed to come first, then it's going to return -1. And if the argument is supposed to come first, then it's going to return +1. So if B is equal to A, this will return 0. If B should come before A, it's going to return -1. And if A should come before B, then it's going to return a positive number. So because of that, actually, I'll keep the rules in here for a second. Because we're saying B, if that comes first, it's -1. What is the ordering that I've just come up with here? What is this array going to look like in the end, once it's all sorted? Any thoughts?
Could you say that again? It's I kind of got lost when you started going. Like I got it when you were doing the normal sorting. but the moment you started adding a function, I got lost.
Yeah, okay. So we have this sorting function here, which is going to compare two arbitrary strings. We don't have any idea which two strings it's going to compare. It could compare any set of strings. It just depends on the underlying implementation of how it's actually going to do it. But the sorting function is going to tell us, do we need to swap two strings? Or like what order should they come in the names array? So we have two things here, A and B. They are two arbitrary strings. Let's say we're comparing Anton and Olga at this moment. So A would represent Anton, and then B is going to represent Olga. And what we need to do is we need to return a negative number if A should come first, a positive number if B should come first. So if Olga should come before Anton, sorry, let's do it the other way. If Anton should come before Olga, A before B, then we should return a negative number. If they are the same string, we can return 0 to indicate it doesn't matter, they're the same string. And then if Olga should come before Anton, then we're going to return a positive number because B should come first in that case. So given that, you'll notice down here that I'm calling locale compare on B against A rather than over here where we say A should produce a negative number if it comes first. So this function, if I swap B and A, the ordering as compared to up here, what do we expect the result of this sort to be? What general ordering should this names array have in the end?
Shouldn't it be the it's gonna be in descending order, right? That means Olga and Niall and then Brandon and Anton would be last, correct?
Yeah,
Okay.
exactly right. So when I swap B and A here, I'm saying whatever this ordering was here, do the opposite. Another way I could do this that might be less confusing would be I compare A to B, which again, this locale compare does exactly what we say up here. If the first argument should come before the second argument, we return a -1. If they're equal, it's 0. Or if the second argument should come first, then we return a +1. If I swap the ordering here, it's just going to put them in the opposite order. And so now if B should come first, then we're returning the opposite value. Or, if we just want to very easily swap the order and we don't want to confuse ourselves, then maybe we could just do something like this instead. Since this returns a number, we could just say use the opposite number. So if we were thinking that A should come first in ascending order, then we make that negative number a positive number. I think the more words I put in here, the more confusing it's going to get. So I'm going to stop talking. But long story short, if we want to swap the order, we just swap the sign of the return value one way or another. We could do some really complicated stuff here. Maybe I have like a bunch of objects. Let's make this a separate array. And we have two objects in here, and they each have a foo property, var1, foo, var2. Well, I don't really have a good ordering for how to sort an object. An object is just like an arbitrary set of keys and values. But I do know that these objects are all going to have this foo property. Maybe since we're using TypeScript, I'll just declare an explicit type for it. Type has foo is equal to an object where foo is a string. So this is an array of has foo objects. And this is valid because they both have this property. If I took that property away, it's no longer valid. So if I want to sort this in ascending order based on this property, maybe you have like users and you want to sort them by age or by the user's name or something like that. I can write a comparison function as well that then, does some other cool stuff. So here, maybe we have A and B. And these are objects now rather than strings.
You wrote names.sort.
Oh, that's why they still appear to be strings. All right, now if I hover over there has foo objects. Great, thanks for the catch. So now I still have to return a number. Maybe I return a.foo.locale compare to b.foo instead. So you can make this logic as complicated as you want. You can compare based on properties, you can compare based on literally anything, and you decide which one should come first and return a negative number or a positive number, depending on what it should be. Let's check these just to make sure they work. So if I run this, realizing this text on my terminal is probably very small. All right, so my first one I sorted in descending order. And so Anton and Brandon and Eli are at the end, and then the things with a lower in the alphabet letter are up front. And then here we sorted according to the foo property, and we did it in ascending order because we put A before B. And so bar 1 is smaller than bar 2 because 1 is less than 2. Cool. So we can sort things in JavaScript. That's cool. You could just tune out here if you want, because honestly, that's all you really need to care about in this language. You're going to use these sort functions in order to just sort an array of any arbitrary thing. You might have like a state array of objects or of strings, and you just want to sort them. Or like you're displaying a bunch of things on a menu or in a table, and you want to sort the rows of the table. You can do something like that. I think for your homework assignment, that's exactly what you have. You have a bunch of to-do items, and you're sorting them in terms of maybe date modified or of their ID or of their name. And so you're writing your own sort functions down here with some logic on the inside, which is great. That's cool. It's great that it's easy, but I personally would be a little curious to know what's going on under the scenes here. So we have two arbitrary strings in this name array. Like, how does it figure out which strings need to be compared? What is it actually doing to say, okay, given these two arbitrary strings and it returned -1, I need to swap those things. So under the hood, JavaScript has implemented their own sorting algorithm. Most languages will have sorting algorithms implemented for you so that you don't have to like write your own, because good sorting algorithms are complicated. I do have a link on here if you're curious about how JavaScript does its sorting to a Stack Overflow post. And it is a little bit different just depending on what browser you use, but a lot of your browsers are going to follow this approach where it picks a specific sorting type depending on what type of data you're sorting. So maybe if I'm sorting strings, there's a better algorithm for sorting strings than it would work for numbers. And for numbers, there's a different algorithm that's even better. You don't have to figure out any of that, which is just fine. But we should at least understand generally how sorting things work. So let's do this. We'll just comment this out. And now down here, I'm going to create another array of numbers. And we'll just put a bunch of random numbers in here, maybe 3, 9, 15, 2, 1, 2, 47. And we want to sort this in ascending order. So we're going to implement our own sorting algorithm really quick. If I were to sort these numbers by hand, not even using any code, maybe just on a piece of paper, and I just cross out the numbers and move them around as needed, can someone give me an idea of like a step-by-step process that I could follow in order to sort this array by hand? Like, what do I have to do? How am I picking things that I need to compare? Anything like that.
Well, I mean, I would like do an oh man, that's a kind of crazy question. I would have done like a number at a time and then you compare, but like I don't like JavaScript doesn't really have like a way to like start moving things around an array because that's how I would be thinking is like you compare each number and then you decide where its location is in the array, right?
I like your thinking. I think we're headed in the right direction. Let's even like not even think about JavaScript for a second. So you're saying maybe we look at the number 3 and we try and figure out where does that fit in my array. And then I look at the number 9 and then I try and figure out where does that fit in my array. And then I look at the number 15 or something like that. That could be
Yeah.
that could be an approach. From like a high level, I can just look at the number 3 and say, well, there's a couple of numbers smaller than it, and there's a couple numbers bigger than it. And so I know that it needs to go in slot number 4. I could do something like that. I could figure out how many things are greater, how many things are less than, and then, put them on either side and just stick it right in the middle, and then look at the next number and do the same thing. That could be one approach. Any other approaches?
By using a comparison function, like we can say a minus b or something like that.
Yeah, so the comparison function is like our high level of we're going to take two values, we're going to compare, figure out which one comes first. And now we need to figure out like, okay, how do we actually pick which two things we're going to compare at one time? And given the result of this comparison function, whether it returned -1 or 1, how do I, know whether I need to swap something around? So let's get even lower level than that. Pick a number.
It would be a battle of numbers. You would start with the first, and then you, and if it can beat another number, then it keeps going up until it can't, and that's how you figure out its placement. So each number battles another.
This is also a really good idea. This is very close to a sorting algorithm already. The name of it off the top of my head, I don't remember. But basically what we do is we say, let's start with this number 3 and let's go all the way to the right and let's just grab the biggest number we can and keep scooting it to the right. Or we could do the same thing with the smallest number. Let's start at the end, try and find the smallest number and scoot it all the way to the right. So maybe if we start with the smallest number, because this is already in the right spot, my numbers array, let's copy this. I would start on the right here and I would say, is 47 greater than 2? Yes, those are in the right order. Let me move on to the next one. Is 2 greater than 1? Yes, those are in the right order. Is 1 greater than 2? No, in which case I need to swap those out. And now I go over here and I say, is 1 greater than 15? No, I need to swap those out. And then we do the same thing. Is 1 greater than 9? No, I need to swap those out. And we do it one more time over here. So I went from all the way on the right and I went all the way left. And what is the result of doing this? We got one really cool thing out of it. We know this 1 is now in the right place. I have found my smallest value and pushed it all the way to the left. And so now I can do another pass through this array. And I can start at the right and find the next smallest value and push it all the way to the left. We know that this is already the smallest value, so we don't even have to look at it again. We could just stop right here now. So are these in the right order? Yes, yes, no, no, and then no again. And now our 1 and our 2 are in the right order. And we do it again on the remaining part of the array. These are in the right order. These ones are not. These ones are not. These ones are not. And you'll notice our array is already sorted. If I were running an algorithm, I wouldn't know that. I just know that because I'm looking at it and I see that it is sorted. But I would also want to go through and do the same thing here. Are these correct? Yes. Are these correct? Yes. I've already went through everything. My array is now sorted. So that's one set of steps we could take. That is a type of sort. I want to say it's called a bubble sort because your numbers sort of bubble up to one side of the array, either the biggest one or the smallest one, depending on which direction you go. There's lots of other kinds of sorts. Another thing we could do is we literally just look through the whole thing and we find what the smallest number is, and then we swap it out in place number 1. We look through it again, find the smallest number, swap in place number 2. I think that one's called an insertion sort off the top of my head. And it accomplishes the same thing that we're doing here. Instead of like swapping things a bunch of times, we're just looking through the whole thing and then swapping 2 numbers at the end. So I would look through and say, 1 is my smallest number. I'm going to put that up here. I'm going to put my 3 back here. And now 2 is the smallest number. And so I'm going to put my 2 over here, and so on and so forth. So let's write some code for this really quick. We'll use, I think we're going to do an insertion sort because I think that's going to be a little easier to read. And we'll say this is our data, which is an array of numbers. And we get back the sorted numeric array. Actually, we don't need to do it. Actually, yeah, we should do it. So we're going to return our number array. And let's write some code for this. So for I is equal to 0.
I'm sorry to stop you. What is happening with this function? What is with the I would have thought you would have just shoved in like numbers as the variable, as the not variable, the parameter, but you're doing a thing where you got data with the empty array, and then you also have you have number with an array, and then you also have number on the outside with an array. What is this?
This is TypeScript. We can maybe clarify some names here just to
Oh.
make it clear. This is not the same as this. So let's say this is my, I don't know, my array. And so I'm declaring a function and I'm calling it and passing in this array of numbers as a parameter. What TypeScript says is this parameter or this argument that my function accepts has a type. This colon says, this is the data, this is the type of that data. What is it? It's an array of numbers. And here we're saying, well, what are we going to return? We're also going to return an array of numbers. So at the end, I would have to make sure that I return my data array back.
Oh, so this is like indicating like what has that be. So like prop type, it's basically saying these
It's exactly the same
things.
thing, except
Yeah.
stricter and even better. I cannot do insertion sort and pass it an array with a string. Cannot do hello, because it's going to tell me immediately that string is not a number. And so this bug that I've introduced by passing an array of the wrong type, because this is expecting a bunch of numbers, well, I can't do that anymore. And so it's caught this error for me. If I did prop types in React, I would have to run my code in order to actually figure out that I did something wrong, because it would only tell me in my console, which is really annoying.
But if I want to pass the string, do I need to use a comma and something I have to assign to there to parameter?
You would have to explicitly say that this argument can also be an array of strings. And then I could also return my array of strings. So this is a union, which says my value can be either this type or this other type. And this is really gross because, you know, if we're sorting things, we want to be able to sort anything that is comparable. So strings, numbers, maybe we have some objects that define how they're going to be compared. And so maybe we don't want to use this union type. Maybe we want to use something called a generic. And a generic, which I don't know the syntax in TypeScript off the top of my head, so I'm not gonna like try and assert that I know. But sure, you could find it pretty easily. This is really gross. But anyway, what it looks like in other languages is we would say, well, the type of this is just some arbitrary type T. It doesn't matter what it is. And I'm going to take in an array of those types. And I'm going to give back an array of those types as well. And what is T? Well, T is something that is comparable. This is not valid TypeScript, by the way. I don't know how to do this in TypeScript, but this is how it would work in Go, which is what I do at work. But what you're saying is we can call this function with any valid type. It could be an array of numbers, it could be an array of strings, it could be an array of objects, it could be an array of Booleans. And we should be able to call insertion sort on any of those things. But we can't just compare any old thing. We can't have like numbers and strings or two different objects that have different properties because comparison isn't defined in that case. And so we explicitly say, whatever this type is, it has to be comparable. And so this would be like an interface, most commonly, that says, whatever this type is, it has to define how do I compare the two and return -1, 0, or 1 to figure out which one should come first. So that's what we would typically do here. Just because I don't know how to do this off the top of my head, we're going to keep it as a number array. But you could take either approach. If we also wanted to pass in strings, I could use a union with that pipe, or I could do something generic. Either one works. All right, let's jump back into things. We're going to do an insertion sort, which we said is go through the whole thing, find the smallest number, stick it in slot 0. So let's do that. So this is my slot 0. And the next iteration, I want to grab from the rest of the array, the smallest number, and stick it in slot 1. And then the next iteration, stick it in slot 2. So we're going to say this I is the slot we're sticking it in. And we're going to make another loop in here. And we're going to start this at I. So if we're trying to figure out what goes in slot 0, we look at everything 0 onwards. And then if we're trying to figure out what goes in slot 1, we look at 1 onwards, and so on and so forth. And let's keep track of smallest thing. And this is going to be a number. And let's make this whatever is in data of I. So it's going to start as the first thing that we can compare, and then we're going to compare it against everything else. If data of J is even smaller, mixing up my language syntax here, then my new smallest thing is going to be data J. And I also want to keep track of the index of where that smallest thing occurred, not just the actual data itself. So we'll put another variable in here. Smallest index number is equal to I, and my smallest index is equal to J. So we keep track of both the data and the actual index. And so this loop will go through, it'll find the smallest thing, it'll keep track of it and update it as we find a new smaller thing. And now that we have the smallest thing, what we're going to do is we're going to do data of I is equal to data of smallest index. Actually, we don't even have to do that because we have the value. It's our smallest thing. And we're going to stick into data of J, or our smallest index, whatever was in I. So it's going to take 3, and it's going to take 1. So J, or the smallest index, is going to be pointed at 1. And our smallest thing is going to be 1. And then I is going to be pointed at 3. And what are we going to do? We're going to take whatever's in slot 0, which is 3, and we're going to stick it into the slot, the smallest index. So 3 is going to go here. And then we have that 1 stored in our smallest thing variable, and that's going to go into slot 0. And so 1 goes in. And then the next iteration, we go on and through the rest. I'm running through this very quickly because I don't want to spend too much time on it. This is a lot to take in. So definitely like, if you want to do some review here, that's just fine. We just like don't have time to like really dig into this. I'm just writing a sorting algorithm so that we can talk about cooler stuff in a second. But let's see if this works. Insertion sort of my array. We're going to console.log the result. So I would expect that this is going to be in ascending order when I run this. Cool. Prints out our array. It's in ascending order. Our sorting algorithm works. If I wanted to do this in reverse, I would have to modify some stuff in here in order to let me do that. But this is like what's happening under the scenes. This is our comparison here. So when we do SumArray.sort, and then we give it a comparison function, and we say, well, if A is less than B, then we're going to return -1. Else if A is equal to B, then we're going to return 0. And otherwise, we're going to return 1. So these are the functions that we wrote further up here, these very generic high-level sorting functions. And under the hood, this comparison function basically replaces this right here, where we're comparing two arbitrary things in the array and figuring out, do I need to swap those two things? And if so, we do something and we're going to swap them. It doesn't, I can't plug this in directly just because of the way that I've written this, but whoever's writing this sorting algorithm will also allow you to provide a comparison function, which would be of type A, which is a number, and B, which is a number, and returns a number. So this comparison function here would be an argument, and then we would use this comparison function instead of this middle part. But we're going to leave this out just for a second. All right, so we have this algorithm. This is what is going on under the hood. This is just one possible way of sorting our things. It's just one set of instructions that the computer can follow. We could do this a bunch of different ways. We could do this a lot smarter. How do we figure out whether this is good or bad? How do we compare this against another sorting algorithm? The other thing we talked about was a bubble sort. So we start at the front and we compare the two, and if they're in the wrong order, we swap them. And then we compare the next two, and if they're in the wrong order, we swap them. And then same thing, so on and so forth. If we were to write that, we could write that as a separate sorting function. But how do we actually compare which one is faster, or if they're exactly the same and it doesn't matter? And the answer to that is that we need to have some way of quantifying space and time complexity of a function, and we do that using big O. Is that what you were about to say?
Yeah, I was gonna say we can check how many times we use the iterations, like.
Yes, we could literally measure it. We could just say, okay, how many times are we actually running through this loop? Well, I goes from 0 up until the length. So let's say that my array is of length 5. Well, I is going to start at 0 and then go to 1, 2, 3, 4, since it's of length 5. And what does J do? Well, every time I changes, we run this internal loop. And so J is going to be 0, and it's going to start at 0. And then it's going to go to 1, it's going to go to 2, it's going to go to 3, it's going to go to 4. Because it also goes up to data.length, but not including. And then what happens when I is 1? Well, we start over, our loop restarts, and J now starts at 1. So in this case, J is going to start at 1, and then it goes to 2, and then it goes to 3, and then it goes to 4. And then the next iteration, I is now 2. So J starts at 2, and then it goes to 3, and then it goes to 4. And it starts at 3, and then it goes to 4. And then it starts at 4, and that's it. Our outer loop has run every time. Our inner loop has run every time. We're done. We return our data. So how many like critical things did I do? So let's say the stuff that happens inside of our J loop is the critical part of our function. Let's quantify this as one operation. I don't know if like literally how long in memory it takes to perform these operations, or like it could take an arbitrary amount of time, but let's say this is one operation. How many operations am I doing? I count 15. Can someone verify?
Yes, 50.
Okay, 15. So we're doing 15 operations. So this insertion sort, let's say, does 15 operations. Well, my bubble sort, maybe that's doing a little bit more work. Actually, it's probably not. It's probably doing the exact same amount of work. So my bubble sort, we're comparing two things at a time. So we do 1, 2, 3, 4, 5 comparisons. And then the next one we do 1, 2, 3, 4 comparisons. Sorry, actually, I'm going to take this out because this should be an array of length 5. So we're going to do 1, 2, 3, 4 comparisons. And then we're going to do 1, 2, 3 comparisons. Then we're going to do 1, 2 comparisons. And then we're going to do 1. So 4 plus 3 plus 2 plus 1 is equal to
10.
10. All right, so our bubble sort in this case is doing 10 operations. Can I comfortably say that my bubble sort is way better than my insertion sort?
Technically, it's 30% faster, right?
Yeah, it is, it takes 2/3 of the time in this case. We generally could say in this specific example that it's faster, where we have just 5 elements. But we need like a general way of comparing two algorithms for any arbitrary input. It might be that our algorithm has some optimizations in it where in some cases it might run really fast. Like we find some really cool scenario, or like our array is already partially sorted. And so it's not actually going to do 15 operations every time. And so instead what we do is we quantify algorithms based on the size of an input. And we can quantify both space, the amount of space that your algorithm uses, and also the amount of time that your algorithm uses. And in both cases, we measure it based on the size of your input, where if my input is really big, how does that scale? If my input is really small, I probably don't care. Sorting 5 things, whatever algorithm I use is going to be really fast. But if I'm sorting millions of things, then I need to like make sure that my algorithm isn't running really, really long. And so we use big O notation, which we would say an algorithm in time complexity runs in O of some algebraic function in relation to n. And I could also say, how much space does it use? Well, it uses some amount of space that is a relation to n. So in this case, I am not creating anything new. All I'm creating is 2 variables. We don't care about individual variables. They're probably very small. It literally might be data that we already have and we're just like pointing to it from somewhere else. And so we don't really care about that. 2 things, like that doesn't matter. So we would say for this algorithm that our space is O of 1. Anytime we just have some constant things, we say that is 1 to imply that it's a constant. If I were to create a new array here, new data, and say, well, this is an array that is going to be everything in my old array, I'm going to spread it out so that it has all the same items. And then maybe down here we do some stuff with new data. Or maybe we're sorting not in place. So I want to create a new array and then sort this array instead so that our original array still looks exactly the same. Well, now we've created an array, and how many things are in here? Well, it's the same number of things as in our data array. And so we say that the number of things in our input is n. And what have we done? We've created an array with n more objects in it. And so our space complexity now is going to be O of n, because we have n new objects in this thing. And let's say I created a newer data array, and I n times I'm going to say newer data dot push a new array that has everything from data. So what is this doing? This is creating a two-dimensional array. So now I have an array of other arrays. So this array has 1, 2, 3, and this array has 1, 2, 3. It's like a square. Well, now how many things do I have? If my original data was of length n being some arbitrary length, we have no idea actually how big this array is. It could be 1,000 elements, it could be 0, it could be 1,000,000. Well, now I'm creating n arrays with n items in them. And so if I were to represent this algebraically, now my space complexity is O of n squared, n times n. We have n arrays of n elements. And we do the same thing with time complexity. So if I have, let's take all of this out for a second. If I have an array of numbers here, and there are n numbers in this array, well, how many operations am I running? Again, this is one operation in here in the critical loop. This thing here, it's not important what we're doing. We're just going to compare for the sake of things in relation to that value n. Well, what am I doing? Well, I'm looping n times. So do n things. I goes from 0 up to, but not including n. And then in here, what am I doing? Well, I'm doing some function that is also in relation to n things. For simplicity, we would say that this is also in relation of n. It gets smaller every time. So in the first loop, I'm doing n things because it starts at 0 and it goes up to the length. And then the next time we do n minus 1 things, and then n minus 2, and so on and so forth. So we do n things times n minus 1, or rather, this would be plus n minus 1. And then the next loop, we do n minus 2 things. We add some more stuff, and then eventually we're only doing one operation, and then we're done. So if I were to put this together in a different way, I could say this is n plus n plus n plus blah, 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 plus n plus 0 plus 1 plus 2 plus blah, 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 plus n minus 2 plus n minus 1. Actually, let's not do this. But essentially, we're just adding a bunch of constants here. And so n gets smaller and smaller, and then our constants get bigger and bigger. This actually is not a perfect relation. I think I've messed this up a little bit. But long story short, the thing that's important is that this is just a bunch of operations. We don't really care because they're constant numbers. What we care about is how many times is n occurring? Well, it's occurring n times. There's a bunch of other numbers that make it smaller, but we're still doing n times n operations, and then we're subtracting a bunch of constants to make it technically smaller. So we still would say that this is running n operations. What have I done here? Is this correct? I might be confusing myself. This is really complicated stuff. This is something you won't really think about unless you're going through a college course where you're talking about recurrence relations. And then you have to like solve algebraically, like what is the runtime of my function? And you kind of do this while we figure out in relation to n, what is actually happening here. And then we, compute it together and we figure out what's going on. But long story short, we consider this to also be n operations, even though each iteration it gets a little smaller, because we're still looping n times, just getting a little smaller. So long story short, we would say that the runtime here is n things times n things. And there's some constants involved down here, but we don't care about the constants. What we care about is as my thing scales, as n gets bigger, how does it grow? Those constants, those are never going to change. If my data array gets longer, those constants are going to be the same. And so we can just discard them. And so here I would say, well, for this algorithm, my runtime is O of n squared. And my space complexity, we didn't create anything else. We just created a couple of variables. This is constant. And this is how I measure this algorithm. It's not a specific case. It's not an exact number. It's just in relation to the size of my input. And my other algorithms that do different things inside here, those n's that we were counting up, those are going to be different. The recurrence relation is going to be different. The math is going to be different. And so maybe there's other searching algorithms that, sorting algorithms that run in n times log of n. So this is logarithms. There are plenty of searching algorithms that can make things smaller. A logarithm of n is going to be smaller than n itself. And so this would be a better runtime than this for a really large scenario. Even better would be if we could just do something in O of n. There's not really any searching or sorting algorithms for that. For the most part, n times log of n is going to be your typical sorting algorithms that you're going to find. There might be some more complicated stuff that can have better scenarios for certain types of arrays. I don't know that off the top of my head, but most things that you'll see implemented in different languages like JavaScript are going to be this. And we're not going to use any of these O of n squared things like insertion sort or bubble sort. They're easier for us to comprehend than these more complicated algorithms that are a little bit faster, which is why we don't have to implement them. That's why JavaScript does it for us. And the other thing to note, runtime and space, typically you'll favor one over the other and you'll choose an algorithm based on that, but they are both important. If I have an algorithm that's like, oh, it runs in O of n instead of n squared, but we're using a ton of space, maybe we're creating like a two-dimensional array here. And if I have a million elements, that's a million times a million slots in that two-dimensional array. That's really big. I probably don't have a lot of space for that in my program, and I don't really want to do that. And so I would have to discard that option. So it's a trade-off. For the most part, I think runtime is usually more important than space complexity, but as your inputs get really big, space is also a problem. So you got to just be cognizant. And this is how we would compare two algorithms. All right, I'm done talking. I'm 7 minutes over. I am available for questions if anyone has any questions or anything they want to clarify. If not, that's all I got. Make sure to sign in using the form, which I can link for you guys really quick, just so I know you were here. And we'll go from there. Next week, I think, is the start of your project and there's no content. So I might be available for office hours, but I will probably not plan for any content. And if you have anything you're curious about or want to work on, feel free to stop by and mention it. But otherwise, we'll just cancel it if no one has anything pressing. But that said, feel free to stick on if you have any questions or drop off. And I might see you guys next week.
I have a quick question.
Go for it.
I'm not gonna lie, I was lost the whole time. Once you started talking about the algorithm, Okay, question.
Sure.
Do I need to like? I understand you like college level. This is important because the difference is, but like at the end of the day, the algorithms are already created. Like the first thing you showed was something that was sorting for us automatically, and then you showed us how the underlying like code would probably run. So I guess the question is, there are already algorithms that are preset in code languages that we will be able to use, right?
In a lot of cases, yes. A lot of very common use cases will be implemented for you in whatever language you're working on, because that's the whole point. Their job is to make it easier for you to write code that does the thing that you need to do. But that's not always the case. You're going to be writing a lot of code that does very domain specific stuff that the creators of JavaScript and Python could not possibly know that you're going to need to do. And so you're going to be writing your own code that also needs to be efficient and not do things that are really long and terrible for big inputs. Maybe I am writing a website that could have thousands of users, and I need to like be able to have like a table of users, and I can search through the whole table. Well, that table also needs to be able to sort the users, but that's thousands of inputs long. This is not a good example because, you know, you can sort, but maybe I'm like looking for a specific user that has a certain property in it. Well, there are ways that I could do that efficiently that would have a smaller runtime, or there's ways I could do it that are really inefficient, and I need to make sure that I know to avoid those. And some of it is intuition, like, you know, if you're going to do a really stupid approach to figuring out like which users have the name Eli, then, you know, that's on you. There's plenty of easy ways to do it without having to do any empirical runtime analysis. But the more complicated the code you write, the more you will come across situations where you do just have to be cognizant of it. A lot of times it's as simple as, well, how can I not put a loop inside of a loop? How can I come up with a more efficient way of doing it? And you don't necessarily have to figure out the exact runtime complexity, but you just need to be able to recognize a loop inside of a loop. If that data gets really big, that could be problematic. If I do a loop inside of a loop inside of a loop, that's really bad when your thing gets bigger and bigger. So how can I come up with a different way of doing it? And so those are sort of like data structure and algorithm questions that you'll get asked in an interview, which you need to be able to come up with an algorithm and describe its runtime. That's a very common problem for like a generic programming interview. Might be different if you're focused specifically on like React or web development. You might get less questions that are like that, but a lot of general programming interviews will ask you stuff like that, so that on the job, you can just naturally be able to say, well, I'm writing this code, but I think it's going to be really inefficient. Let me try and find a better way, even if you don't have to come up with the exact runtime off the top of your head.
So this might be a dumb question, but what like doesn't SQL like couldn't you like write SQL queries because SQL sorts for you, right? So like you're talking about the user thing, like wouldn't like
Yeah,
inserting SQL queries into your code to run that type of algorithm for you?
this is a very specific example. And in that case, yes, there's other ways of doing things. There's always other ways of doing.
Yeah,
So
that
like
makes
if I'm
sense.
requesting a bunch of users from a server and then I need to sort them, I can either ask the server to sort it and then whatever query it's making to like an SQL database or to like a MongoDB database, which is an SQL, it just uses a bunch of like free structured documents. Like they will have ways to sort the data themselves. And maybe that's more efficient, just delegating it to someone else rather than coming up with your own approach. In this homework, you're going to do both. You're going to let Airtable sort it for you by passing something in the URL to just say, sort it for me, I don't care. And then you're going to take that out and instead implement your own sort in JavaScript by just writing a comparison function, not writing this complicated logic here. It's all trade-offs. Computer science literally is just trade-offs. Everything is a trade-off. Sometimes it's really easy to figure out which one is better than the other. And sometimes neither scenario is great and you just have to pick the lesser of two evils. And being able to compare things to figure out, okay, why is this better than something else is really important.
Could you please share us the demo, the one we made? in the
Yeah,
class?
I can put this on a GitHub somewhere. And put that in the links with the video, which I'll post tonight.
Okay, thank you.
I also have one more. I wanted to know, like, because I'm assuming like I haven't checked this week's lesson, but I wanted to know, like, is there a way to be able to specify what you want from an array? So like you were doing a number array, but like is there a way to be like, I just want to know that does this array contain 45? Like,
There
or
are
this array
other,
says 15, like is there a way to filter out everything else and just return number 15? Because that's what I'm asking for. So
yeah,
like the search bar in that thing, so like when I type it in, like that thing will pop up.
yes. This is another scenario of the language developers know that this is a common use case, being able to search through an array to find something or to filter out objects in your array that don't match a certain criteria. And so there are just arrays, like methods on the array type that do this for you. So sort is a function of an array that does that thing, but there's also other functions. So there is a filter function where you go through the array and you give it what's called a predicate function, which just like runs on every single item. And if you return true, it keeps it. If you return false, it discards it. And then you get back a new array. So I could say filter my array. And for every number A, I want you to keep it if A is equal to 3. And we'll console.log the result of this filter. And we'll comment all of this out since this is broken code. If I run this, the only thing I have left is 3. That's a very common use case. Language developers know that. And so there's another, there's a method for it. And there's a couple other ones that you might be interested in. Like there's .sort and there's other things too. I'm trying to remember what the cool ones are. There's for each, which says for every value in my array, just do something. Maybe I want to console.log every individual value. And so I can say for each value in my array, just log it. And now if I run it, it's just going to print each individual value, or I could do something more complicated here. So yeah, this is another case of there are conveniences. You don't have to do all the implementation stuff down here. You don't have to worry about what the runtime is of doing this. You just get to use the convenience of JavaScript.
Okay.
Anything else?
So to compound on that question, so, and this will be the last thing because I know you're over.
That's right.
So like in my head when I was watching this and like I was thinking about it, in a search bar, you would, when you're typing something out, you would probably use like an event listener that's on change, right? So every time a person types in a letter, like it starts sorting during that moment. But when you were using those things, like it wouldn't, whenever you would type it, it would just show false until you get to the exact thing because it's looking for exact. So like, is that like, because I know I'm pretty sure there's like ways, like you did the Eli versus Elijah thing. So like if you were to type in ELI, it would show like, would it show Elijah? Basically what I'm saying, should it show Elijah and Eli at the same time? Because when you're using something like on change, it's supposed to, like, it will be searching, it will be using that function every time something happens if you do that. Does that make sense?
It does. And I think this is a great use case for the filter function. So I could say, instead of doing an exact comparison, we names.filter, let's make this current search term. And let's say they're halfway through. So we have that on-change listener. Again, this is not a React project, so we're not going to have anything in here. And they've started typing EL, and we want to show them only Eli and Elijah and take out Bob and Robert because they don't match the criteria. Well, I could use a filter and say for each item, keep it if, what are we going to do? Well, here I would say that we're going to check if a.to lowercase dot starts with current search term dot to lowercase. And we'll comment all of this out again. So what is this doing? This is going through each item in names, and it's going to do this comparison here. It's going to take A, which is some arbitrary value in here. It's going to make it lowercase, and then it's going to check, does it start with whatever I am searching for, also lowercase, so that we have that fair comparison. And if so, this returns true, since this returns a Boolean, and my filter says anything that returns true, we want to keep. Anything that returns false is going to get discarded. So now if I run this, oops. What did I do? I don't think I have that for each anymore. Oh, I do still. Let's try it again. All right, maybe this doesn't quite work. Why doesn't this work? Starts with search term dot to lowercase. Names dot filter. This feels like very, oh, it's because I didn't return anything here. It actually returned the Boolean so that it knows. All right, there we go. So now it's filtering only things that start with EL or Elijah. So you can utilize this, like for the most part, you should be able to do almost anything you want with arrays just by using these cool functions. It's just changing like what the actual parameter function is based on your domain use case. That's why they provide it for you in this very generic form where I'm going to filter and then you can pass me any function.
Thank you. I didn't know that there was a starts with. You call the. That's actually a question I never knew. The blue is all the blue text functions, correct?
Yes, these are all functions. That's
Yeah.
just how it highlights it. If you're ever curious what functions are available on a type, I usually just make a literal version of the type. So in this case, I want to figure out what string functions are there. And I can do a dot and it'll just suggest these all for me. There's lots of really cool things you can do here. All very generic things you don't have to worry about doing yourself. And they provide for you in this very English-friendly way of saying, well, what is actually happening, even if I don't care about the implementation? Well, I'm filtering this array by doing this comparison. How does the filter work? I don't know. I could probably go in there and figure it out and dig around, but it doesn't matter. It just tells me in English what is actually happening. So definitely worth exploring. Some of this you just come across the more work that you do. So I wouldn't, like spend years and years pouring through documentation. You'll come across some of it just based on your needs.
Thank you.
You're welcome.
Have a good night.
All right, same to you. See you guys next week.
Thank you. Bye-bye.